Okay. Good morning, everyone.
Good morning.
So we are not very many today. So we'll just go like a discussion. Like I like the way the last Fazizo did it. The businessman that Kule brought was like a discussion. So we just go like a discussion since this is a closely knit group of not too many people. So IT landscape and careers. Actually, this topic came when I was talking to Bayo. Bayo and I were having a discussion a couple weeks back, and after the cybersecurity event, and he suggested that we should do something like this so that people can I can at least we can have a discussion on IT and the different careers, the different domains of IT, and the careers that are available in those domains. I mean, so back in the day when we were in secondary school, for those of us on this set, the careers there, the leading careers at the time was you be a doctor or an engineer or you'll be a lawyer or you'll be a lawyer. Those were the leading careers, or you'll be a nurse. At the time, we didn't know, but the internet wasn't in Nigeria yet, I'd say. And even in the US, across the world, 1995, internet was restricted to the military. Computer education and the role the computer played in society had not gone this deep. But this is 2020. IT has created a vast number of careers. And the thing about it is that while IT itself used to be a standalone industry and career, it's no longer like that. All the traditional jobs that existed before IT became this pervasive are now being transformed with technology. So you're not just an accountant, you're not just a salesman. IT is shaping it, it's transforming how you do everything. So knowledge about the computer and how the IT space works is absolutely indispensable at this time. So it's a good time. I was hoping that we'll have more people, but the announcement came very, very late because what we will discuss today will be helpful for people who want to do a career switch, who are looking at IT to make a career switch to decide how they will enter, where they will enter IT. For our children too, for those of us who are, of course, who are raising children, you're looking at these children, you know their characteristics, you know their passions. You can begin to see, for those of them who want to do IT, what part of IT is good for them, will fit their behavioral competencies more perfectly. And of course, if you also have like younger, like Mr. Ogidi told me, like you have a word, a younger brother, somebody you're mentoring who wants to go into IT, this will also be very, very helpful for them. I didn't start my career in IT. I had an HND I have an HND in electronics engineering, and then I worked in engineering for a while. I worked in marketing in Nigeria. I came to the US and then I did a master's in information science, information systems management, MISM, and that's how I got into IT. So I graduated in 2014. So over the past 6 years, I've worked in IT, predominantly in the management level, just leading IT projects, running IT operations. So that has exposed me to a broad category of IT domains and how the whole thing fits together. That's my career background. So to start things up, the agenda for today, I've built an IT network neighborhood. What I've come to understand about IT is that explaining the whole ecospace is there's a very, very simple analogy, which is like a normal human neighborhood. You can explain a lot of IT concepts using the neighborhood, and then we are going to talk about these IT domains, starting from networking and systems administration, cloud computing, software development, cybersecurity, data analytics, artificial intelligence. This is not all that IT is. There's a lot more that I didn't cover. There are certain things I didn't cover that I remember too late. I couldn't, it was too late for me to put them in, like identity and access management, ERP rollout, ERP expert, like people who roll out like Oracle and SAP and all these different already built applications for businesses. That's a part of IT too that I did not cover. But these are the core domains of IT for the most part. So let's talk about the IT network neighborhood, which is what I use as an analogy. So you look at a neighborhood, you have houses, you have the roads, you have the traffic lights on the roads to control traffic, you have cars driving on the road, you have domiciles, you have houses that people live in, you have business houses like shops and malls, you have this there's a mall and the parking lot. You have houses that people live in, you have houses that people don't live in but serve the community, like a church, like a mall, like the public pool and things like that. So I'm going to use all these things as an analogy. When you look at a neighborhood like that, for an IT network, the roads in the neighborhood, they are like, in the, using my analogy, they are like the network cables that make the network a network. And so when two computers are connected to each other, that's how a network starts. The same way roads link houses and places. That's so the cables, that's the highway for the data packets to go through. In this neighborhood, the vehicles and the people represent the data packets that are actually going from one place to the other. When you pull up your email at work, when you go into the ERP system that you use, when you whatever it is you do on your computer, you are sending data packets back and forth. They are going through these highways. Now, that starting with the highways, that is very important because there are categories of highways. You can have a footpath like jungle. Larry knows very well about footpaths because he used to hang out in the jungle with grandpa. So you can have footpaths, you can have one-way roads, you have like interstate highways, very big ones. That's exactly the way it is in network cabling. You have Cat 5. Cat means category. Starting from Cat 3, Cat 4, Cat 5, Cat 5E, Cat 6 to fiber. All of these categories are sizes of cables, not in terms of their physical size, but in terms of the amount of data that can pass through these cables successfully. So if you walk in a place, for instance, and if people are having a lot of latency issues on the network and things are slow, one of the places that network engineers will begin to look at is what is the underlying cabling in this building anyway. If it's anything less than Cat 5E, Cat 5E, anything less than Cat 5E, that's old. If any organization that has less than Cat 5E now, they need to start talking about a project to recable their network because the amount of data we are pushing now is too big for anything less than that. Most are on Cat 6. Fiber is very expensive, but it's of course that's the interstate highway, very, very big, can pass a lot of data through because it uses light technology. So you have vehicles and people, data packets, everything is in data. But data packets are also not the same in texture and size. I think the biggest ones that I'm aware of are like video and audio data packets. They consume a lot of space on that highway. And then you have the normal data packets that go back and forth. So you want to enter this neighborhood, there's a city gate. That's essentially a firewall. The firewalls are security gates that are placed at the entrance of networks or a sub-network to filter traffic to say, oh, you this data packet, where are you coming from? You're coming from China. Your IP address. You're not supposed to be getting any traffic from China. I'm going to block you. You're not coming in. You are the right data packet coming. That's what a firewall is. It's a security gate that filters network flow and blocks some data off. And you are the one that the company, when you set up the firewall, you set it up that way. You choose what traffic goes and what traffic doesn't go. Traffic lights, these are like routers and switches. So when you hear about routers and switches, they are directing data packets from from switches within a sub network, and then a router is like between two large networks and each other. That's why what you have in your house is called a wireless router, because your house is like a network. Every computer, cell phone connected to your house It's its own sub network, and then your router links you to the internet. So routers and switches, they are basically traffic wardens. That's the role they do, essentially. And then I call the houses, that's the domiciled houses, the people living in this neighborhood. That's like the PCs that we use, along with other peripheral devices like scanners, printers, multifunctional devices, and things like that, but computers generally. Then the business buildings, the mall where you go to shop, the government building where you go to file for your driver's license, the church where you go to worship. These are also houses, but they are usually skyscrapers. They have bigger reinforcement, they are stronger. That's what the servers are. A server is essentially, at its basic definition, it's a computer that has tremendous more resources than a normal computer. Now, servers can be software, so I don't want to tie it down. Like the traditional belief is that a server is a physical device. Yes, but not necessarily. There are servers that are software, but they still have to be inside a physical device. These days, you can have a single physical device that has multiple servers inside it, like web servers. A web server is a software. It's a Apache Tomcat, for instance. That's a web server for building web applications. It is a software, but it has to stay inside something. So if it's bare metal, that means that the server application is installed into the server host. But I don't want to go away with the impression. Server can be software or hardware or both. But essentially, they provide services to users, other computers, or other network resources. So, and they are basically a server. I just want to make it clear that a server is essentially a, a computer with tremendous resources because it provides service. For example, when you get to work and you click on Microsoft Outlook, the Microsoft Outlook is just your application on your computer. Your email itself is inside a server called the Microsoft Exchange server. That is where the email is. That is whatever host that is, it has to have more resources than your laptop because multiple laptops are sending traffic to the Microsoft Exchange server where the email resides, while the Outlook is just a desktop client. So, and then I also went ahead and the roles. So, because much of what we'll be talking about today is like the different roles in IT, and it's again, it's analogous to the different roles that people play in the society. So the town planners and architects, those are the people that will design, okay, the stadium has to be in this side of the city. And because the stadium is there, you cannot have the largest shopping mall beside it. That will be too much traffic. Let's put the shopping mall on that side. The churches will be here. The distance will be here. They will slice and dice the land and make sure that the right things are in the right places. For example, if you have the incinerator, waste disposal, whatever here, then the domicile houses should be there. If there's a school here, there shouldn't be a bar in front. That's what network engineers, solutions architects, that's what they do on the network. They're the ones that determine how the whole network is laid out. The town planners will say, okay, this place just needs a single lane road, this back and forth. No, but if you want to go from here to here, you need a bigger dual carriageway. So they determine what kind of cable goes here, what kind of cable goes there, how this one will move traffic here. They shape the network, they architect it. That's what network engineers do, and solutions, network architects, cloud solutions architects. Anytime you hire, that's what they do. And then you have the system administrators. That's the maintenance department, where the community has been built, everything has been laid out. The community, the maintenance department have to be there to come in every time. There's a fire burning. The firefighters will come and plug it into the hydrant and spray the water. Some building has collapsed. They will call these people to come and pack the rubbles. A pipe has broken. The water pipe has broken. The water people will come. They maintain it. They maintain the community. That's what systems administrators do. When the network engineers have built the network, they have placed the servers in place, they have sublimed the net, they have divided the network as necessary. Sys admins are the ones that stay behind and run the network and make sure everything works as it should work. Um, the help desk support people that you interface with at work every day, or even when you call MTN for you have a network issue. Those are the doctors, those are like the healthcare people. They help you, they help people. Anybody who provides help. Those are like the doctors and nurses who treat people when the people are sick. And then you have the cybersecurity team. They protect the network from criminals. That's what the police does in the community. There are other service providers, like people who sell in the market, people who provide all sorts of services. Those are like application developers, and application developers. And the analogy is so beautiful in the sense that people who sell, they're in the marketplace, they're in the mall. People who provide services, they're in some big business building or so. So when developers develop applications, they are installed and deployed into servers. So that's why I compared service providers to application developers. And then you have the artists in the community who beautify the community with billboards and, and paintings and graffiti and things like that. I refer to these ones as like the UX and front-end developers. And we'll talk about that later. People who sit down and say, yes, we have built the application. It does what we want it to do, but how do we make it attractive and easy for people to follow? The taxonomy of any web page that you go to, there's a lot of research that goes into it to say, okay, this is where we put in login button. This is where we put in our logo. This is where we put in this part because this is what people are likely to look at. All of this is the front-end developers, the user interface developers developing things. HMI means human-machine interaction. There's a whole industry of HMI experts who study people and they study how people browse and determine how to lay out any application's interface. What page? Your landing page. For the landing page, which one goes next? Which one goes next? All of this is there. The clergy is in society to remind us that, you know what, your lifestyle is not good. You need to go back to God. You need to start behaving properly. For me, these are the quality assurance people. These are the information systems auditors. They audit the environment. Auditors they can audit your cybersecurity posture. They can audit how you're using information, your data classification, and things like that. Should customer service representative be seeing the salary of everybody in the company? That's not right. So they will classify data, they will shape it up. So this level of data, only this level of people should see it. And if your company is not following it, depending on the regulations of your industry, auditors will pick that out. Quality assurance people will discuss them again in software development. They're the ones that will compare the requirements that the client gave to what the developers built, and they will say, oh no, this is not what the client asked for. You have to change that. It's not working the way it was supposed to work. So there's a very, very good analogy between the IT ecospace and the human environment that we live. Let me start with the NOC and the data center, the network operation center and the data center. So everything I described right now, usually a lot of this is the data center. In data center, you have this, that's where the servers live. All of that, those long things you see, they are called racks. Those are racks. And all these racks, they have spaces. So that's where you put in all your network equipment. The firewall sits there, the servers sit there, the router, the router sits there, the network infrastructure sits there. So the data centers, it depends. There are small ones, there are big ones. There are ones that are massive, like for the big companies. Data centers sprawl miles just because of the amount of data they deal with. Data centers host data. They are the heart of every network. That's where apart from your PCs and your printers and whatever the employees use or that you use, everything else, for the most part, is sitting in the network, in the data center and the network operation center. So data center, for the big ones, they will have an operation center in the middle. And you see all those screens, they are monitoring the performance of all of these devices to make sure that they're performing well. So let me tell you the different jobs in the data center. That data center, as you're looking at it, if you walk into it, a normal person, you would think you're walking into a fridge because it's very, very cold. All these devices, they generate a tremendous amount of heat, but they cannot afford to be hot. If they start getting hot, they will start misbehaving. So data centers have a lot of HVAC experts that work there to make sure that they maintain the temperature, humidity, and all of those weather conditions. You have probes all over the place measuring. If the temperature goes too high beyond, you see the alerts. Then they will go and see what's going on. Did one HVAC air conditioner go bad or something? They'll go and repair it. Or if the humidity, there's so much water in the whatever in the atmosphere, it will spoil these things. They will go and quickly adjust things. So there's a whole lot of careers, network engineers, backup engineers that work here. And of course, and that's how they work essentially. They monitor, they look at things, they maintain things where they should be. From network engineers and facilities people. Now, you also have data centers have a high level of security, physical security, apart from cyber security, physical security. The data centers that I've visited, the big ones that I visited one. I was talking about in the group one time. That is where some of the American security agencies host their systems. The amount of man traps that you have to go through, and then biometric scanning, everything. Because if you are able to gain access into this place, you don't need to hack, and you know what to do. You can wreak a lot of damage. So they have a lot of security here as well. And of course, they have a lot of cybersecurity experts. They have a lot of telecommunications engineers outside of network engineers, because as you're looking at it, any data center usually has a network hub where they will bring in cabling from that's my daughter, please. That's Rachel Anjoorin. That's my daughter. I wanted her to see this transition. So they will bring in cabling from, like in the US now. Any average data center should have no less than 3 internet. Any average data center have. Sorry about that. Hold on. So so you have like Comcast internet, AT&T internet, T-Mobile internet. They will all enter into a single room, and then that is what will power the internet in this place. So there's a lot of jobs, both physical. Then there's safety. We have a safety expert in our set. That's Moko. Safety people will be here because data centers, they are not so, because they have to have fire protection, but they cannot just have water sprinklers, because if the fire breaks out and water sprinkles down, it will damage all of these things. These are electronic devices. So they use, there's some specialized gases that we call them dry gas that we use. In many places, though, they will still have the water sprinklers, but there will be like a series connection so that if a fire breaks out, it is the gas that will deploy. It's only when the gas does not kill the fire, maybe like in instance of like a bomb blast, something really, really bad, and it's going to burn the whole building. At that time, you don't care about the electronic equipment anymore. It's already done. They will let the water, then the water sprinklers will go. But normally it will be a dry gas. I've forgotten the name of the dry gas, FM something, FM 600 or so. That is what they use for fire protection. So they have safety experts, fire safety experts that work in this place as well. And I'm going through this because I want us to see what's at the back end of everything that we click upon. There's a whole lot of different careers there. Okay. So now let's talk about networking. It's a field of computer science that deals with how computing devices, not just computers, cell phones, computers, servers, routers, switches, Wi-Fi, even network printers, any equipment. And in your industry, I may not be mentioning the right names because different industries have different things. Like when I work with Guinness, we have what we call PLC, that's programmable logic controllers. Anybody who works in a place where there's flow, pipes and steam, oxygen, hot water pipes, all of that, they use SCADA. So it could be any equipment on the device, of course. The networking career is always going to be relevant. If it's shrinking, a lot of people are not going into it, but it's always going to be there because wired networking is always going to be at the heart of IT before we talk about wireless. So it's the basis for communication in IT. making it a fundamental knowledge to have, honestly, irrespective of your IT specialization. It doesn't matter what your IT specialization is. If you have a good sense of how the network works, it always helps. You could be a database expert, you could be an AI expert, you could be a cybersecurity expert, you could be a software developer. It doesn't matter. If you understand how the network works, it helps you. The best IT people that I know, that I've worked with, that I've seen, they come from a background where they've touched all of these things. So that when your database is not working well, and you try to troubleshoot your code, those who have been in the network, they will say, Omo, there's a switch in this place. Is this place having issues? No, it's the switch. That subnet, that switch doesn't have enough bandwidth. I remember when we installed it, is a 2 gigahertz switch, and we have just added 10 employees there. I don't think that switch is passing traffic well. It gives IT professionals a deeper understanding when IT issues start. So it's like I said, it's a lot of people, it's not popular because it's not cool. It's backend, it's hidden. You're not seeing, you're not creating cool apps, but this is the heart of it. So you have clients, clients are the devices that we use, that end users use. Servers, we're talking about you love IP addresses, network devices, firewalls, routers. This is the world of networking. And the careers, um, let me talk about the careers. Typically, you start from a network technician. Those are the help desk guys. It goes from like tier one, tier two, tier three, based on your level of experience. If you're coming straight from like an associate's, which is like an ND in Nigeria, or a bachelor's, you don't have any work experience, potentially you can start from the help desk, with your helping people to move computers, joining computers to the domain, resetting passwords, and then you go to tier two, you begin to solve some more deeper issues, and then tier three. Tier three now becomes like tier three. Once you are like the tier three help desk role, you're already approaching being a network administrator. You know how to configure your router, you know how to configure a switch, you know how to configure the firewall to make sure that it allows open this port to make sure that this kind of traffic comes through, or block a port. So you go from network technician, network administrator, to network engineer and architect. So network administrator essentially sits in the company and administer the network. They are more of like the maintenance department I talked about. Network engineers or architects, they are the ones that look at the network and reconstruct it. They do major work. They reconstruct it to optimize it for some business purpose or need. That's high level. These are the high level guys. They don't Network engineers don't work inside business companies, except those business companies are very large. A lot of them will work with like the actual telecommunications companies, or they will be consultants who will come and help people do stuff. So that's the career. And then how to get into networking. A bachelor's degree in computer science, computer engineering is good. An associate is good. And even if you don't have all of that, there's a lot of certifications that people can take from Cisco, CCNA, Cisco Certified Network Administrator, GNC, and that's Juniper Network, CCNP. There's a whole lot of certifications out there. You can start from CompTIA Network Plus. That CompTIA Network Plus helps you understand what these things are and how they relate to each other. And then you can go from there. That's the field of networking. If you ask me, I would say people who are prone, who have affinity for engineering, for hands-on engineering, because when you're working in networking, the reason why I use these pictures, okay, I've not gotten to. So working in networking engineering, you'll be touching cables, you'll be crimping cables, you will be using pliers, you'll be using cutters, you'll be using equipment. Your hands are going to get dirty. So it's good for people who want to work here in networking to have an affinity for hands-on engineering. If you don't have affinity for hands-on engineering like me, and you like to write and stuff, yeah, I don't think you have the best affinity for networking. It doesn't mean you cannot succeed in it. I just think because I work with them and I see how they are. These are the engineers. So system administrators. So System administrators and they work with the network administrators. Like the systems administrator role is very, very, very closely knit to the networking domain, because they are the ones that actually configure servers. They configure servers, they set up virtual servers, they can program networking devices. So they can program networking devices, and when somebody is joining the organization, they add it to they create your accounts, they put the necessary permission levels on it. They can touch all of the network devices, routers. So when we say network devices, broad category, there are traffic wardens and there are houses. Houses are servers. Houses are servers. Traffic wardens are firewall, router, switch. They direct traffic. So those are core network devices. Typically, network administrator touches those, but system administrators touch those as well. However, when it comes to the internal workings of the servers, because there's a lot of servers on the network, you have the DNS server, DHCP server, database servers, web servers, multiple, all sorts of servers. It could be Linux operating system, it could be Windows server operating systems, Ubuntu. There's a whole different lot of operating systems. Knowing those operating systems in those servers, that is the expertise of the sysadmins. So the sysadmins, these are geeks. They write scripts, they issue commands, they write code, but the kind of code that they write is not code to build business applications. It's code that talks directly to the heart of the computer. They instruct, they command the computer to do stuff. They don't build applications. So that is what sysadmins do. It's less physically involving than network administration or network technician or network network technician. The sysadmin can just sit at their computer and do 90 to 95% of their work is on the computer. That's what it is. If something goes bad and something is not there, we go and check the data center to make sure everything goes well. They can say, oh, this cable is bad, or this light is not flashing. They can do all of that. But what the deep network work, they will transfer to the network administrator. These are geeks. They're also back end. They sit in the back end and they just monitor systems, configure them to maintain and operate. Again, associate bachelor's in computer science is good. More of computer science than computer engineering, in my opinion. And then these certifications: Microsoft Certified Practitioner, Microsoft Certified Systems Administrator, and Red Hat. The reason why I've started Linux Systems Administrator is because Windows servers usually administer them from a GUI where you can click stuff, and drag stuff. Linux Systems Administration, you're really not using the GUI. You're talking to what they call it the terminal. It's a whole dark screen, and all you're doing is just writing scripts, issuing commands. So Linux System Administration is not as friendly as Windows Systems Administration. It's a little bit more difficult. And because of that, there are fewer people who do it than Windows Administration, but it commands a lot more money. I mean, the more difficult any domain is, the less people will be in it, and therefore the more money will be in it. So Linux is a power skill, guys. I mean, these guys make a lot of money. Linux System Administration. Windows Administrators too, they make money, but more Linux people make a lot of money. More, I would say, because of the level of difficulty it poses. So now we'll go to cloud computing. So the data center I talked about, the cloud summarily is, so the data center I talked about, an organization might have their own data center. It might be small. When I was an IT manager a couple of years ago, a data center had maybe like 5 racks, no more than 60 servers. So, but that's a small, I'm only a small organization. So that's a small data center. Big data centers, they have thousands and thousands of devices, and they are very, very large. if I understand that, I don't know if it's Facebook or Amazon, they built some data centers buried in the ground right by the ocean. So it uses the cooling effect of the ocean to cool that data center. I mean, a whole lot of crazy stuff that these people, data centers are typically not announced. Their location is not publicized because they are one of the targets that terrorists look for. Because if you can break down a data center, you would destroy access for a whole lot of people. So it's a potential terrorist target. So it's not something you just see willy nilly. Oh, it's a data center, come and visit. It's a little bit, it's like a surgical theater. So the cloud is a whole lot of data centers that you use applications installed in them, but you don't own those data centers. You don't know where they are. You don't know how many routers, IHOPs that your traffic is journeying through. You don't know. You just pay a company to host your application. That company will give you a URL www.businesssolutions.org. You log into it, you start your work on a daily basis. You don't care about the storage drives. You don't care about the cabling. You don't care about cooling the data center. You don't even know where it is. It's like renting an apartment. It's like renting an apartment. You don't have to deal with the landlord deals with all the wahala. You just live in it. That's what the cloud essentially is. The sea of data centers. When they draw network, the term cloud came about. So if you look at this network diagram and you now imagine you're trying to draw for a metropolis or a state, trying to identify where a specific data center is, it becomes a cloudy mess of a network diagram. And that's how they say, you know what? Going forward, we'll just represent all of these jargons as the cloud. Period. That's where the cloud comes from. So cloud computing is is not new, but it has evolved tremendously. It's like the in thing right now. Many organizations don't want to be concerned about all the wahala that data centers do. Because if you sell beer, if you're Nigerian breweries, for instance, if you're big and sensitive, but if you're a regular business, if you're a school or a church, you don't want to be hiring a HVAC person to be maintaining. You don't want to be hiring. There's a whole lot of things going on in the data center that you don't want to be paying somebody. You're responsible for their health allowance, medical allowance, all sorts of things if they get injured that companies don't want to. So they want to reduce staff to just say, you know what, all of this, let's just go and rent it. All I need to do is for people to enter, log in, and do their work. I don't want to be involved with all of this nonsense. So they would then contract it out to another company. That is cloud. It's already the cloud at that point. So cloud computing is very, very big. Like I said, it's not new. It's a practice of sharing computer resources, delivering services through the internet via remote servers instead of having local ones. That's all it is. A remote server that you don't own, you just rent, and you're not responsible for. You don't know where it is. You don't care where it is. It's just there, and it's not new. Like I said, um, when we opened our Yahoo Mail many years ago, we were already using the cloud. When we opened our Facebook accounts, we were already using the cloud because we don't own those applications. We don't know where they're hosted. You don't know where your email is right now. Even WhatsApp, we don't know the IP address of the server where our chat is. Zoom, we don't know the server that is hosting our call right now. All of these applications, they are all cloud because cloud has different categories. You have software as a service, infrastructure as a service, platform as a service, even desktop as a service. When I was doing my master's, we only told there was three. Yesterday, when I was doing the final research for the slides, I saw that there was also desktop. I was like, when did this one start? And I began to dig into it and see. I also saw data as a service. I was like, you know what? That is the nature of IT. It's constantly evolving, constantly changing, and expanding. But right now, cloud has exploded with a whole lot of roles, and new technologies led by Amazon Web Services that people have. So the traditional roles that people used to have in their company, network admin, sysadmin, all of that, they have equivalent on the cloud, but with a different skill set. All these, you're not going to be pulling wires, you're not going to be plugging things, you're not even going to be configuring a router. You're just going to be essentially, instead of placing a physical device in the rack that I talked about earlier, you just click a button and that thing comes to life. The firewall comes to life, you place it, the server comes to life, you slice and dice, the storage comes to life. It's the cloud is amazing. If anybody wants to go into IT now, the cloud is a good place to start. Although it would be best if you had some knowledge of how the network is, the traditional network is, like what DNS is, like what border gateway protocol is, what dynamic host configuration protocol. There's a whole lot of terminologies and things that once you have a familiarity with them, then you can now, learning this will be easier. It will be easier, it will not be all new. So there's a whole lot of rules, like I said, too many to count, but all of them trace back to the traditional rules of on-premises. So essentially, if it's not cloud, it's on-prem. We call it on-prem, which is on-premises. That means that our server is on our premises or it's in the cloud. So all of those on-prem roles have their cloud equivalents and more. So you have cloud engineer, you have DevOps engineer, you have cloud reliability engineer, you have cloud infrastructure engineer, cloud developer. I didn't finish defining these things. My bad. I didn't finish defining them, but there's a whole lot of rules on there that can be that you can convert into and begin to learn. And then all of them have a lot of resources for you to teach people. That is the good thing, because all of the leading cloud companies, Amazon Web Services, Microsoft Azure, Google Cloud, IBM Cloud, and all of the rest, they all do the same thing, but they do it in different ways. The knowledge is transferable between one platform to the next. They do the same thing, just in different ways, and they all have courses. Like they have set up all of this training and certification online that you can go through. I would recommend, if you want to go to cloud, please choose AWS. AWS is leading and shaping the industry. I'm predicting that over time, a lot of the other companies, they will need to start not converting, but they will start embracing how AWS does things, because that is where the chunk of the market is. So the way it works in IT, where companies begin to agree is that if you own a chunk of the market, if you are up to 60% or 70% of the market, and you do things this way, and a small company that has like 10% of the market or 15% of the market comes, and you have your own customers, unfortunately for your customers, they are going to be dealing with a lot of people in the 70% one. You don't want to ask those people to change to your process. You just want to adjust. So the larger dog in the industry will shape the industry. That first mover advantage, it will shape the industry. So I recommend, if you want to start cloud, choose AWS. I've heard that their training is very, very good. I have a lot of friends doing it. I haven't done it yet, but Azure is good. But you can start from anyone: Google Cloud, Azure, all of that. But AWS is the leader right now. And a background in computer science is good. A background in networking is good. No background at all is good, but you have to learn some background things to be able to fly in this industry. A lot of the cloud infrastructure rides on Linux operating system. So those who have experience or knowledge of Linux scripting, they have tremendous advantage when they go to the cloud. A lot of the times you'll be hearing, you already be able to place them to know what they are and how it fits into the new jigsaw puzzle you're dealing with. So let's now talk about software development. I picked up the definition from Wikipedia. The definition is very, very good. Software development is the process of conceiving, specifying, designing, programming, documenting, testing, and bug fixing involved in creating and maintaining applications, frameworks, or other software components. That definition is really good because it's all encompassing. A lot of the times when we talk about software development, most people just automatically go to programmer. It's like the programmer is as if that's the only thing that exists in software development. No, it's a whole cycle. And that is why I wanted to deal with the cycle. We call it the SDLC, the software development life cycle, and the different roles that are attendant upon them. So the number one, planning. When Bigway wants to float a new application, or Wally wants to start a new company, needs some sort of software built. The person who wants it built is called the vision owner, the client, the customer. That's who they are. That's where it starts. The first person they're going to hire, they're going to get to start the planning is a project manager who's going to listen to them and then craft a project to build what they want. So the project manager is very, very important because 80% of IT projects, of software development projects fail, 80%. And majority of the failure lies between the project manager and the business analyst. They're not even the coders. They don't write the code. They don't, but they start the process. The project manager is having to identify the scope of work that we're going to do. How much work are we doing? How much will it cost? And how much time will it take? Where are we going to buy things? Where are we going to hire things? What are the risks? All of these things. And then it goes to the business analyst. And then you go to the software developer. So you go from planning to analysis, which is analyzing what the vision owner wants, and then using that analysis, creating requirements, which is the heartbeat of what is going to be designed, what is going to be coded. So the business analyst will get the requirements. Using the requirements, the software developers will now begin to design this is how this app is going to look. These are the number of classes we are going to write. This is how many tables database we'll have, and all of that. After the design, please mute, please, if you're here. So after you do the design, you begin to implement. The implementation now will require somebody from the hardware part, because now you have to get the server, all the cloud. Somebody has to architect the cloud. You deploy the application on it. And then after that, the QA tester now comes. The QA tester, those are like the people that will now compare what they basically compare what the business analyst wrote in the requirements and what the programmer wrote, developed in the application, to say, does it match? If the requirement said this, only people with @gmail.com should be able to log in to this application. The QA tester will now go and test and put somebody with @yahoo.com, put somebody at hotmail.com to make sure that that requirement is made. They compare what was supposed to be built and what was built. And then they will find out all the bugs. They will let the cycle will start again. They will go back to the developer. So this thing is not working at all, or it's not working right. So then they will go through all the bugs. And after all of that is done, testing is done, the application has passed. Now it will be taken over by the domain experts who actually use it. There will be training. The training could be done by any number of people. Usually in the process, the domain experts, like the heads of department, the managers, the supervisors of the different domains, they will be in the project. So they will start crafting the training documents for the users, for the employees, or the whoever's going to be using it. And then they'll start training people how to use it. And so the maintenance of it, like I said, the domain experts, the systems administrators, the software developers, they all collaborate to make sure that this thing is maintained. It takes that's the go live part, and okay, the application is stable. The software developer roles diminishes at that point. The systems administrator becomes just watching and monitoring to make sure things work. The domain experts are the domain experts, which is the everyday user of that application that takes over. So this is the development life cycle and the different jobs attendant upon each phase of the cycle. So like I said, the project manager, he leads the project and bears responsibility for the whole project end to end. They manage the scope, the budget, the schedule, the procurement, the things to buy, the different stakeholders, the quality, the risk. There's about 10 fields that the PMP identified. All of that the project manager will do. The behavioral competency that's required. A project manager should be a good people person, should be a good communicator. Again, they say 70 to 80% of what a project manager does is communication. You know, can come from any number of educational backgrounds, but you have some business experience. A project manager is best when they have people that come fresh from school. If you come fresh from school and you do a PMP, you can pass it, but when you start working, you will need to learn. Project management, I think, is a domain that you learn while doing it and getting all sorts of experience across board. So the leading certifications are the PMP. The PMP has an agile track now, certified Scrum Master. I know, Faye, if I mute you, please stay muted, okay? Stop unmuting yourself. Okay, so leading certifications, like I said, PMP, Scrum Master. These are the things, these are the kind of certifications you do to be a project manager. It's one of the good entry points into IT for mid-career people. It doesn't matter what career you had, a teacher, a pilot, a doctor. I mean, when I did training classes for this, I was in training classes with literally everybody because every industry has projects. So project manager is such an agnostic career. And what they say is that you don't even need to have any knowledge of the domain. You don't need to be a doctor or a nurse to be a project manager in healthcare, or to be an engineer to be a project manager in an engineering project. Helps, it's good, but you don't have to be. If you understand project management framework, you'll be able to apply it and use the domain experts of that area to identify what will go into the schedule and into the scope, because there's a lot more that makes a project successful than what the subject matter experts do and make happen. So yeah, that's a good place for mid-career switchers to get into IT. Then let's do the business analyst. I like this picture. It's usually used anywhere there's a business analyst discussion going on. And it says, this is how the customer explained it. This is how the project manager understood it and documented it. This is how the engineer designed it. This is how the technician, which is the software developer, wrote it. Actually, this is what the customer really wanted. There's always a gap between what the customer wants and what they say. And trust me, in fact, a lot of times, they can't even, what they have in their head and what they are telling you doesn't match. You will have to understand, you have to elicit. That's why we call it requirements solicitation or requirements elicitation. You pull it out. Sometimes you will show them, a lot of times from my experience, what they are telling you will not be what they want until you show them an example of what they want. Do you want it to look like this? Oh, yes. And what they were saying in the beginning, if you wrote it down, that's not what it was. So a lot of people, they are in their head to communicate it out so that it can be designed as they want and developed as they want. There's always a gap in that area. And that's why business analysis is an important part of software development. They are, I call them that they're like language interpreters. They will listen to the client who has the vision and understand what the client wants. And then they will write it out in requirements. There's business requirements, there's functional requirements, and technical requirements. And all these buckets, needs to be documented clearly, line by line. The application must do this. The application must have that. The application must have this. The application must do that. Must be able to support at least 100 concurrent users. Must be able, line by line, from logging. In fact, the whole gamut. That's what the business analyst does. They elicit requirements. They validate those requirements. Validating means after they document it all, they will go back to the client and say, "This is what you want, Abi. This is what you want, Abi. Okay." Analyze it, document it, and when they document those requirements, that is what the developer is going to use. Most developers are geeks. They are not people persons. That is why these roles are important. Most developers are not patient. You understand? They are not like Kunle Ogidi, you understand, or me, or they love to talk to the machine. They are so logical. There's no gray area with machine. You issue the command, it will give you exactly what you want. With human beings, it's not like that. You have to interpret for human beings. So because of what I would call the inherent lack in the developer's behavioral competency, these roles, they are as important as the developer in software development. So they speak with the customer, understand what he wants, convert us into requirements. You have to be very, very friendly and patient because of the tactics you use. You might be shadowing. You just go and take a seat beside the person who's working, whose process you're trying to capture. And you'll be asking them questions. Oh, what do you click that? People will snap at you because I've done this job. People will snap at you. Sometimes they have deadly, crazy deadlines. They don't have time. You're just watching and you're writing down. Then later you ask them questions. So you do all of that. A people person with a curious mind, good interrogating, listening skills, writing skills would be a good business analyst. Anybody from any career can be a business analyst. It's more of once you can write well, you are patient enough to listen and document. I think you have what it takes. You could be fine arts, anything, anybody. You can. I believe. I'm not trying to belittle it, but if you're patient and a listener and you know how to write, you do this job. There are certifications for it. There's no bachelor's or associates for business analysis, but there are certifications for it. It's a kind of job that rests on some kind of previous education that you already have, and it's a very, very it's a very good transition point into IT too, because it's a soft skill. I wouldn't call it a soft skill, even though business analysts, the industry will tell you it's a hard skill. I consider it a soft skill. It's more approachable. You can switch into this career, go for a training, learn how, because there's a lot to it, user stories and all sorts of tools that they use, Kanban board, run down this, it's all sorts of things in it that you need to know, but they are easily learned, especially if you go and take like a PMI, professional in business analysis, IIBA, certified professional. These are good places to start being a business analyst. So now we go to we're going through the cycle. The software developer, somebody who writes computer programs, is a software developer. And there are different software development, I think, is the biggest breadth of work in IT because everything is software. This Zoom call is software. Your Windows 10 is software. That's what they call embedded software. People who write software for essentially operating systems that come preloaded in equipment, in devices. Web development. A lot of times from the average user end, we don't see development beyond a web developer, a app developer, or a games developer, but everything needs to be developed, like everything, tools. For those who write programs, like there's all these platforms we use for data science, for programming, for SQL Server, all of those things is software. You buy a camera, you buy a cell phone, Android. The Android operating system is software. It was written by people. So software development is so freaking large, guys. So freaking large. I think a background in computer science is a good starting point to be a software developer. And of course, and then you have to learn the languages. I consider them the magicians because they create things that didn't exist before, just out of an idea. They will create it and you begin to see it. They use, for me, these are the people that use the creative power of God. They imagine something and they just create it and then it is. And people begin to use it that wasn't there before. So let me start with the web developer because that's not the most common now, but the mobile developer is the largest group of developers in the development industry today because mobile has gone crazy, it has exploded. But originally it was web developers developing applications that can be uploaded and hosted on the internet. So the web application, this is the general structure. It's not always the case, but the general structure. You have the front end, you have the back end. The front end is the part that you and I click on the computer. The back end starts with the web server is where the front end is hosted. Like I said, you're clicking on Gmail, you're checking your email, you're clicking on an HTML page that is residing in a web server somewhere. Then there's an application server. That is the logic part. If you do e-commerce, if you do procurement, anything that you do, there's logic behind it. That sits in the application server. And then there's always a database where the data actually sits that you're pulling or that you're entering. You enter a name of a person, their address, their zip code, you click, it's going through into the database, going through the web server, through the application server where the logic is. The logic is going to manipulate it. If you're supposed to enter, to put some money, if you're buying something on e-commerce, for instance, the web server is where you're clicking on. After you click and you click buy, the 12% tax will be added to it. Freight will be added to it. All of that logic is in the application server. That is the heart of the application. And then the database is where the data sits, where your name is, where your credit card information is. That's the seat of the data. So then each one of those layers has a tremendous different jobs. Like I said, there's a front-end developer, the people that develop the front-end, that's the user interface. You'll be an expert at HTML, CSS, and JavaScript. These are the three main languages.
On the floor. Okay.
So these are the three main languages for front-end developers. And artistic minds excel here. If you don't have a sense of how layouts can be made simple and pretty and attractive, you will need to do a lot of learning. Otherwise, you can develop the front end, it will work, but it will be ugly. If you see some of the if you go to a website and the landing page is just not attractive to you, doesn't grab you, they didn't do a good job of the front end development. And it's a career. It's a big career. Big career. Then the back end, they are the ones that develop the heart, the logic part of the application. Very large. They use Java, C++, Python, PHP, Ruby on Rails, .NET framework. There's a whole different lot of languages that you can use. Some languages work well with certain purposes, and some languages work well with certain purposes. Baba Benmuto. So those are the backend that develop the logic part of, and that. So all of these languages, they are all jobs. HTML, CS, these ones, HTML and CSS, you have to know both essentially. They are married together. And JavaScript is added on top. You should know that for front-end development. These are all jobs. Java, if you are an expert at Java, that's a job. C++, Python, all of these languages, guys, we're talking about hundreds, thousands of jobs. because these are the developers. Now, the full stack developer doesn't just major on the front end or the back end. The full stack developer develops both across board. Matter of fact, from front end, back end, database, well, because somebody a full stack developer, they can do it all. They can do it all. SQL, all of that, they do all of that. So, and of course, they don't become more expensive than just the front end developer and the back end developer. If you Google, if you go to Indeed.com, let me see. Hold on. I mean, these are the jobs. These are the jobs, guys. Let me see. If you go to Indeed.com, for instance, and I say Java developer, find job, there's 29,000 jobs, almost 30,000 jobs on Indeed right now that Java related, just Java related. If I say front end, let's just say front end developer. React, 7,000 jobs. So these are jobs. These are the latest technology, React, JS, JavaScript, like that. A lot of them are remote. That is why a lot of projects in the US, the developers are in India. A lot of developers, a lot are in India, a lot, because it's remote. So these are the jobs, man. Like all of these are jobs. Like Python. Let me try PHP. $7,000 jobs. So yeah, so this is it. And then full stack. Let me say full stack developer. And as you can see, these are high paying jobs. These are not full stack developer. 12,000 jobs right here. Remote optional for different kinds of purposes. So these are the guys. You know, everybody in IT is a guy, but I love these guys because you have an idea and you just put something, you create something. You create something you can see from an idea that didn't exist before. So mobile developers, I understand that mobile developers are the largest, that's the biggest part of mobile development now. Of course, the two prevalent operating systems, iOS and Android. There are iOS developers, there are Android developers. There's enough opportunities in each one. You don't need to. iOS used to be the biggest, but now Android developers are more just because of the global reach of Android. iOS is strong in the US, iOS development, but Android generally all over the place. And these are the languages that they use. iOS uses Java and Kotlin for the most part. Android uses Swift and Objective-C. There's a lot of jobs in this area for you to learn. The architecture of the architecture of mobile apps is a little different, can be different from the typical web application. So the learning path is not mapped one-to-one. I don't think you need to know everything that a web developer knows to be a mobile developer. You can learn this on its own and develop apps. So that's also very, very, very good. The thing about development, I didn't go into, I'm not going to go into games, but so there's all, like I said, there's healthcare. Every industry uses software. Every industry uses software. Auto mechanic people, healthcare people, farmers, all of these softwares are developed by people. Even artificial intelligence, even you go back all the way, all of these things. As you can see, the lady, she's typing on something. Anything you are clicking on and typing on is a software written by somebody. So all of these networks, in fact, right now, there's something they call networking is changing into SD-WAN, software-defined wide area networking. Like what they are doing is a whole lot of this equipment you're seeing are now being virtualized. In the next 20, 30 years, all of this equipment you are seeing in all these racks, maybe one or two devices will be there, and the remaining one of them will now become files. They become folders in those two equipment because they will become virtualized. Virtualization is converting what will have been a physical device using software code into literally a folder. Virtual appliances, we have virtual appliances now. We have full servers, of course, that are software, full PCs that are software, full routers, full firewalls that are straight software. It will do exactly the same thing that a physical device does, but it will save you power because you don't have to electrify it. It will save you cooling because you don't have to, it's not generating any heat. So virtualization is taking over infrastructure. Companies like VMware and Citrix, they are running this virtualization. And virtualization is software development. So every part of IT, software development is relevant. It's taking over. The cloud that we're talking about is all software. Somebody writes, in fact, Windows 7 and Windows 10. I met somebody recently who told me that Windows 10 has about 15 million lines of code. It's all code. Everything we are clicking on is embedded software because these are operating systems. So developers is beyond just developing apps and games and business applications, is everywhere. I believe that software development, if anybody has the desire to let their children go into it, it's good to expose it to them young, from a very early stage, because it's a thinking style, the way they think. You know, when you are like my age, I want to start. Let's just say it's more difficult, but from a younger age is easier. Okay. So the QA tester, after the business analyst has documented requirements, after the developer has written all the code, then comes the spoiler to test the code to determine if it does exactly what the requirements asked for. That spoiler is the QA tester. It's a good entry point as well because you get all the requirements. There's something we call requirements traceability matrix. This is this requirement. This is this feature that is the application that was built to do it. Today, does the feature do what the requirement wanted? Yes, no, you mark, you cross. Those are bugs. Those are cute. It's a good place to also start. Requires training. You will need to go for training because it also has zone, whatever. You have white box testing, black box testing, gray box testing, testing, all different kinds of testing that exist in this industry is also a very, very large industry because it has to be there. All of these people have to be there to make a proper quality assurance tester. Sometimes they are called QA analyst. Okay, QA tester, 836 jobs. Let me try analyst. 2,000 jobs. So they have to be there, that they're part of the cycle. So there's jobs out there for this. It's a good entry point for mid-career people who want to join the IT industry because it will make you be in the environment. You start hearing the lingo, you start seeing what people do, and then you can begin to pick on, oh, I like this part. I like this part. Let me go and learn more about this part. So that's the QA tester. Any questions so far? Hello? Are you guys there?
Yes, we are here.
I have a question. I have one question, but when you finish.
Okay.
Thank you.
Okay. So let's go to cybersecurity. Cybersecurity is large. Again, it's very, very large because everything needs to be secured. And summarily, what I would say about getting to cybersecurity is that just the basic traditional wisdom. If you want to protect something, you at least need to know what it is. You need to know where the doors, if you want to protect a house, if you want to protect a neighborhood, you should at least know the roads that go into the neighborhood. You should know the bush that can be used, the fence, where the fence is, where the hill is, So if you want to go to cybersecurity, some level of familiarity with IT networks is good to start. Is good so that you know what you're protecting, you know what, because it's so deep. It's very, very deep, man. Like it goes very deep. So the practice of cybersecurity is essentially protecting, they call it CIA, the confidentiality, integrity, and availability of data. That's what they define cybersecurity as, to protect the confidentiality, integrity, and availability of data. And these are the roles. Cybersecurity is one of the areas that when Kule sent me the flyer, I put cybersecurity expert. I said, man, I don't be cybersecurity expert too, like as it. But so I worked with one of my friends to prepare all these slides, and she helped me for this cybersecurity part. Um, the 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 starting point for most people who choose cybersecurity is the security analyst. And what the security analyst is doing is essentially watching alerts to make sure that to detect what alerts could be a threat and escalating that. So there's something we can call the security operations center. It's pretty similar to the network operations center that I showed in the beginning. It's pretty similar to that. The SOC, you have people just sitting down in front of computers and they are just monitoring traffic going in and out of the network. So the SOC analyst or the security analyst is like the starting point. You don't really need to know much. You just need to be able to pay attention, do what you ask you to do, and the alerts are coming in. This traffic is coming in from Russia. So we're supposed to get a Russia IP address showed up, the alert will come. Somebody's trying to get into the firewall, the alert will come. It's like hundreds of thousands. They have a lot of algorithms that filter them because nobody can pay attention to all of the alerts that are coming. These logs, they log alerts in the millions of records, but they have algorithms that will at least throw up the likely ones that you should pay attention to. So the SOC analyst, the security analyst, they are the first line of defense in this security framework, in the practice. And then the security engineer, that goes deeper than the analyst, analyze the environment, they design security controls for likely threats. So it can be there are specialties, like software engineering cuts across board, cybersecurity, because everything needs to be protected. Mobile apps need security. Databases need security. The cloud needs security. Artificial intelligence needs security. Networks need security. So you can focus and major in a particular area. Network security engineer, application security engineer, web security engineer, cloud security engineer. These are all different jobs. So when they are the ones that essentially will design the security control. Security control is anything we put in place to protect the network or the system. That's a security control. It could be a policy, because by security controls, yes, they call it technical security controls, administrative security controls. All passwords in this organization must have capital letter, uppercase, lowercase, number, and special character, cannot be less than 8 characters. That's a policy, so it's administrative security control. And then you have the ones that actually go in and block a port or implement something. That's a technical security control. So that's what security engineers do. They look at the environment of the network or the application. For example, what's this thing that they do? Buffer overflow. If you have a text, if you have a field that can enter number and I go to enter like 1 billion, like 12 numbers, I can cause a buffer overflow in your application. It's the application security expert that will say, you know, the way you wrote this code, they work with the developers. The way you wrote this code, I can easily crash your application. Why don't you build part of this code to make sure that if anybody enters any number of characters more than 12, the application will not accept it, because if you accept it, it's going to crash your application. So that's what security engineers do for the different parts. Security architects. These are security engineers who have been in the industry for a season, for a good season. They are veterans, 10 to 15 years. They then manage the cybersecurity program for an organization, you know, in the context of that business. Security consultants like Mr. Moyo, the first husband, these are the seasoned people. They are like the experts that come from outside the organization when the internal security team needs help. These people know everything that needs to be done in security. So they will help you. Security, there are companies, there are usually companies like FireEye, Mendiant, they know security inside out. They lead the industry. They are on the cutting edge of it. So they help organizations develop the right program for the environment. You have auditors who come to check the security maturity and measures against the industry requirements, because every industry, like this last week, for instance, I had to craft a security policy in my place of work. I work in the government. So what happened was, there's a department we have, they check criminal information. They have to assess the criminal information of people. We have a place at work with a special network. The employees who do that, who go to check, they don't even use their daily computers. We have a special place built for that purpose. There are computers there. That's the only thing you do on those computers. You check that information system. It's like a website for the information you need to give to the police or to the judge for a judgment. It's crimes information center is what it is. But now the pandemic is forcing all those people to work from home. So this highly sensitive system that you can't even access on your normal work computer, you're going to be accessing from home. So I had, as the IT leader of the organization, the FBI had written, there's a long document from the FBI that they've written along with the Department of Justice stating the requirements for remote access to this application. So I had to read that and then develop our own policy. Okay, so when everybody had to sign that policy, who works in the necessary department. You are going to do a separate VLAN on your home router. So the regular network that you use, that you give to your friends or your people that your children watch Netflix on, they're going to create a separate VLAN. You're going to get a separate room in your house where you're going to place this computer. We'll give you a screen filter. You have to put it on top of it. Now you have to use multi-factor authentication to log in. All sorts of security controls that I had to write out of that document that our employees had to sign before they can access that from home, because that is the industry standard for where I work. So every industry has standards. The government of every country has done this to protect customers' data. It doesn't matter whether they are a private business, Amazon, e-commerce, they have security, they have minimum requirements, standards from the different governing organizations. So a security auditor will come into your organization to assess, to see your practices, your controls, if it is meeting up to the industry requirements. All of these buckets are jobs and jobs and jobs out there. Penetration tester, these are the people that come on an annual basis, at least on an annual basis. It is expected that every organization should do a penetration test. And the penetration test is have people come who will try to hack your network. That's it. That's what a pen test is. You know who they are. Usually the IT leader and the CEO, they will know that this is happening, but all the employees will not know, because it is you we are coming to check. It is you we are coming to check. So if I'm a pen tester, I mean, I can just come to your organization, knock on the door, say, listen, I'll wear a suit and pretend, try to social engineer you into letting me, giving me access into the building, because I'll make you feel like I have a meeting with your boss and I'm late. And then I'll enter into your building, I'll see an open port. If you don't have what they call network access control, where every port that is not used is blocked by the network admin. So I plug my computer into it, boom, I'm in your network, and I'm beginning to extract data. This is what penetration testers do. They come to probe your security architecture to find the loopholes for it. When they find it, they will submit the reports to you so that you can go and block those loopholes, whether they are practices or whether they are tools. Incident responder, they are like, they work. So if there's a breach, if there's a successful breach, there's a whole incident management career track that exists in cybersecurity. You say, okay, alert this person, alert this person, alert this person, cut off the internet, cut off this one, tell everybody to go. Usually the organization should have a cybersecurity incident management plan. That is what the incident responders do. These are jobs. Forensic analyst. Oh, somebody logged into the server from somewhere we don't know. We need to track it. These are the people that will go and do the forensic tracking. Deep. They will go deep into the heart of the computer to extract logs that tells about things. So they perform investigative analysis to determine the root cause of a cyber attack. I've had to hire a forensic analyst once because one of my network admins did something they weren't supposed to do. They assessed a certain place they weren't supposed to do. And this is the thing about IT people at the back end. There's something we call access, and then we have authorization. There's a triple A triad: access, authorization, and accounting. Just because you have the key to go into, just because I give you my key of my house, doesn't mean I've authorized you to go into my house anytime you feel like. So you can have access, but you may not have authorization. For example, if you work as a network administrator for any company, you have the username and password to log into the Exchange server anytime. It doesn't mean you can go and be checking the email of the HR director or the finance director. You don't have the authorization to do that. If you're going to do that, you need an express authorization from your IT director or IT manager to say that. So when people misuse these things, a forensic analyst can come and check and say, who logged into this system from which computer? Even if they spoofed the IP address, whatever it is, these guys, they go deep, they investigate. They are very, very good with hardware. They are seasoned IT people. Apart from government institutions like the FBI and the NSA and things like that, they are usually consultants. Not many companies will hire a forensic analyst to be a part of the team, except they are not roles that are that common, essentially. They are usually consultants. And of course, you have the administrative roles that go from security manager, security director, to the chief information security officer. The CISO is the pinnacle of the administrative roles in cybersecurity in organizations. And in this role, you manage a team, you manage the projects, the staff, the budget, the director manages potentially multiple teams, and the CISO just watches over everything. So you can also pursue a career in this role. You take a certification in IT, in cybersecurity, like the CISSP. So there are hybrid roles, like I was talking about, because security cuts across so many domains. There are so many hybrid roles that exist, and this is not just in cybersecurity; it's in everywhere. You can be a cloud engineer from a security perspective. All of this, there's just too many roles. Depending on the need of the organization, they create a role to meet that need and requiring certain skills. Data scientist, security data scientist, cloud security engineer. These are some of the hybrid roles out there. Getting into a career, an associate's, a bachelor's, computer engineering, computer science, or any related course is good. It's good to have, like I said, a network or system administration's background because you need to know the city or the neighborhood you are protecting for you to protect it effectively. And then for a mid-career switch, a master's in cybersecurity management is good. That way you can get into the management part of cybersecurity. You can pursue this certification, Certified Ethical Hacker, Computer Security Plus, CISM, CISSP. CISSP, I think, is the golden certification of that industry. It's very, very large. So please, that link, I will send a PDF of this slide out. If you click on that link, it has a lot of information on how to pursue a career in cybersecurity. And then we'll go to the world of data. Was this man that said, without data, you are just another person with an opinion. Data rules the world right now. The practice of data analysis and data analytics is basically.
Hello, Joe.
Yes, sir.
Sorry to cut you short. I need to run, but I have a question. Maybe
Okay.
you answer it now, or you can answer it later, and then when I get back to watch the YouTube link, I can find the answer to my question. My question is that in all of this, for majority of us, I mean, let me speak for myself. For me personally, I am an old dog that cannot learn new tricks. I doubt if I can do anything with IT right now other than just enjoy the benefits it brings. You know, where is the money? Show me where the money is. Is it in software? Is it in cloud? Is it in whatever it is? So that the day one boy or one girl comes to me to say, Daddy, I want to do so and so in IT. If he or she is not pointing to where the money is, I will tell the person to go and get himself or herself serious. Where exactly is this money? So that I know where to mine, please. That's all I have as a question.
Okay. Show
You
me.
can answer it later. When I watch the YouTube link, I will find it.
Okay. Summarily, the money is everywhere. Well, they are more lucrative. Absolutely. This
Yeah,
data.
I want to know the lucrative ones.
Okay, see, this data world is money. Hold on. Data science is money. If you are a very good Linux is money. Cloud is money. Baba, all these things are money. If you are an expert at any of these cloud roles, you are making 6 figures and above. Easy.
In dollars or naira.
Dollars.
God bless you. I will watch the YouTube link later. Thanks, guys.
Software.
Kunle, before you go, please can I ask Kunle a question before you? Kunle, are you still there?
I'm here.
Yeah, you can't just be asking us where the money is. You can share where you are getting the money as well. We can't just be watching you make all the money. So if you can have a class of your own where you just share your secrets to wealth, we would like to know as well. Thank you. Bye-bye. Have a good day.
Okay, so Juwon, thank you so much. I think it's a very good one. Thank you. God bless you.
Okay, no problem. Should we? Let me see. Should we continue or maybe I'm off track?
Yeah. No, go on, please. Thank you.
So the world of data. Then, Kule, I don't know whether you're gone. Software development, the coder part, the developer part, that's money. If you have skills in those areas, so data analysis and data analytics. This is when you essentially get data, usually business-related data, and you analyze it to understand the trends for your organization or your industry, and then you present it to the organization's leadership to understand what is going on, to guide their investments, to guide what they pay attention to, is using data to make sense of business decisions. You understand? So more often than not is applied in business scenarios. That's why the word business is used. So like,
But sorry to interrupt. Can I
yeah,
interrupt?
yes, go
You
ahead.
don't need to be an IT person to be a data analytic or to do data analysis. You can be a business person and do data analysis.
I mean, yes, that is true. Data analytics or data analysis is not, it really has nothing to do with the domains that I touched earlier that has to do with coding or infrastructure or anything. It's its own world. It's an application layer thing. You just get data on your computer. If you're good with Microsoft Excel, but it's part of IT. The reason why I put it in here is because it's all part of information technology, or information systems, the domain. But you don't have to, like, these careers don't, it's not like cybersecurity feeds, don't feel it. This is its own world where you use data. You get a lot of data, you acquire the skills to analyze the data, and then you begin to work on it. Like I said, from Microsoft Excel, like Microsoft Excel is one of the most powerful softwares that I know. Like, it's amazing. It's a tool that you use in data analysis. So you examine large sets of data, identify trends. Hold on, please. So the data analysts who get the business data, they analyze it and create charts and visual presentations to help their bosses make strategic decisions. If you work at an organization where you prepare a weekly report based on the number of something that came in, the number of something that came in, and you prepare a chart, you prepare a graph, whatever it is, this is all data analytics. When you start preparing dashboards, there are specific tools like Tableau that you can then learn to prepare not just this kind of charts, but actual dashboards. So what the dashboards are, they are like a digital web page where you can put in a query, a code that extracts data, and you'll have written the analytics into it. So every week, your director just needs to go log on to that web page, and it will present to him the data as necessary for that time because it's fed directly into the source of the data. It's not a chart, it's a BI tool that we call them query. We call it a query. If you write a query to say to analyze some kind of data and you just place it here and you put data sources to it, it will constantly refresh itself. You don't need to run it every time on Excel. You need to get the data again for this week, put it in Excel, and get the graph for this week. You don't need to do that. The BI dashboard will do it for you because it's tied to the data source. So that's a BI developer. And then you have the database manager, the warehouse manager. These are the people that manage where the data is stored. They are more close to infrastructure because now they have to talk about the hard drives in the server. They have to partition the hard drive to say, okay, this is where we're going to put the log file of the database. This is where we're going to put what's the other one? The other file of the database to make sure it runs well. Because when data starts increasing in databases, if the infrastructure hosting it is not well built and well structured, pulling the data will become slow. You become slow. So the database and warehousing managers, they are the ones that say, okay, oh, this server needs no less than 24 gigs of RAM. Oh, I would need to partition it into 3 different parts so that all the people that are pulling reporting, they are pulling from this one, from this database. The people that are updating data, they'll be pulling from the database. I will set up a transactional replication so that by every 5 minutes, this database updates this one. It's the same. It will be just a 5-minute lag, with 1 minute lag. It could be 1 day. So this is what the database and warehousing managers as database administrators do. They design, they develop, and maintain the data storage and warehouse systems. I've done that job before as well, and it's fun. I've done BI developer as well, and it is fun. BI developer is more fun because you meet the leaders of the organization, a lot of times to justify what your data saying. You have to explain to them. See, this one grew from between the last quarter and this quarter. This particular business metric grew this way. That means that our customers are beginning to do this, or this new product has also come to the market. It has cannibalized 30% of our market base. All of that, you're helping them make decisions at the business. That's data analytics. Data science goes deeper. It's more sinister, is less visible, and is extremely mathematical. It's like a combination of combining a lot of mathematical skills with coding skills to make sense of a lot of big data. It explores the science of studying data, applies mathematical and statistical methods. So programming languages like Python and R have become very popular today. In these languages, it's like you're writing mathematics. You can write like, I haven't done this job. I know people who do it. I've seen them do it. They make way more money than data analytics. It is estimated that a data scientist in the US makes between $120,000 and $150,000 per year. That is what these are the big way or should some means. They are numbers people. They love to be with numbers and they love mathematics. Just leave them with that. They crunch it, they make sense of complex data to actually shape industry trends for artificial intelligence and things. That's what data scientists do. Data scientists will lead us into artificial intelligence because artificial intelligence uses a lot of what the data scientists do to do what they do. Data engineers are pretty similar to like the database warehousing managers. They structure the hosting, the infrastructure that stores data, they build it, they structure it properly. Even if it's in the cloud, you don't need to, even if it's in the cloud, you still need to structure it properly. So one of the biggest issues with performance of IT systems, anytime anything is struggling, an application is slow, even the internet is slow, anything that has to do with the performance of any IT system, it usually goes back to, of course, the engineering of the infrastructure, to the base where whatever it is we are doing is seated. If it's not well built, it's not going to work very, very well. And sometimes it's well built for a season. For example, you start a business and you have this structure of your database. You had 100,000 customers. A pandemic happens, all of a sudden, your Zoom, your DocuSign becomes the in thing. So you go from 100,000 customers to like 10 million customers all of a sudden. That's a whole lot of new traffic that the infrastructure you built before may not be able to deal with. So you might need to rebuild and move your data because it needs a whole new different, maybe you had a bungalow before, now you need a house. Now you need a mansion rather to host your data and to support the data and the number of transactions that are going back and forth. That is what these data engineers do. They prepare big data infrastructure. And of course, you have the architect, which sits above that. All of these, they feed into each other. They create the blueprint. The architect is now not just preparing the data infrastructure, but in the context of many other things. Where is the industry going? What will my company be doing in the next 5 years? What are the strategic objectives of this company? Yeah, this is the direction we are going for hosting our data long term. So these are high paying jobs, very, very high paying jobs. They are not jobs, they are jobs that require an intense amount of time with data and computers. So if you're a people's person, I think you're less suited for this kind of job. This job is for the quiet people who can just sit down at the computer and geek it out and crunch data for hours. The thing about these jobs, including software development, is that if you don't have the personality, the money will not keep you in it because it will frustrate, it will suck the life out of you. If you are doing software development, every time you write a piece of code that doesn't work, that has not worked, it doesn't matter what you're doing. You could be playing with your kids, You could be in the stadium. You could be sleeping. I kid you not. That code will be in your head. And you keep running it through. Now. But this is a function I use. It's a personality type. I don't think, and that's the part I wanted to tell Kunle before he left, actually. You need to check your personality type for you or for a person before choosing a career path for them. I mean, it's not a problem to go into a career and switch. IT is good for that. But to sustain long-term in any career in this industry, please recognize that you need to have a penchant for it. It needs to fit into, mix with who you are inside, not just because you are looking for money. Otherwise, you are extremely frustrated in it. You won't last very long. So these are geeks. These are scientists. These are laboratory people. So this is a table that I just put together because data science, data analysts, honestly speaking, it's a lot of people, because they feed into each other closely, but they are not the same. Data science just goes deeper and they deal with a humongous larger amount of data. They are not working for a business person who wants to make profit just like that. They are literally shaping industries. This is bigger than that. Than that. So when we see reports from budget IT talking about our budget, that's data analytics. That's not data science yet. But when you start talking about the amount of data that an Uber autonomous vehicle collects just by taking that number of pictures and driving around, all of that data that they then use to teach that vehicle, that's data science. Creating the predictive models for it, that's data science. It's a lot of data work. So data takes us into AI. Artificial intelligence is this is the breakthrough of IT, in my opinion. It's like using large amounts of data to teach machines to mimic human intelligence. That is my definition, because it's the most basic way to. I saw the different definitions online, but this is what it is. Human beings, we have 5 senses: sight, taste, smell, touch, and hearing. When you begin to teach computers to hear, to recognize the difference between my voice and Larry's voice, and my accent and Larry's accent, and to go and do something as a result, that's artificial intelligence. This is the future. This is the now, and this is the future. Everything is going AI. The AI landscape.
Everything.
Okay.
As in everything.
It cannot be everything now, but I mean. Look, let me tell you what they have predicted. In 50 years, more Americans will have robots as their partners than human beings. Have you seen that?
Clarify.
Why are you disturbing him?
So,
down.
There was a report that came out that in 50 years, all these mannequins that people buy, all these sex toys that people buy, then
they'll become wives and husbands. Yes, I saw that.
Yes, because they are teaching them so much that they are now beginning to show emotions, literally speaking. So artificial intelligence was limited, in my opinion. This is my opinion, okay? It was like there's 2 parts of intelligence for human beings. There's IQ and emotional intelligence. And for the longest part, because IQ is logical. You understand? It's how you analyze physics, mathematics, and all of that. It's your brilliance and stuff. It's easier to teach a machine that. I've always thought, how do you want to teach a machine emotional intelligence? I know that Dede is angry right now. Let me not talk to him. Let me wait. You know the way our African mothers used to deal with our husbands, all of those things, which is not written in the book, is using, but they are teaching machines. Machines are learning emotional intelligence because of facial recognition, because they can sense temperature. A lot of the things that we didn't think had made any sense. The way your eyes do when you are angry, your expression when you are happy. Machines are learning that. And using that learning, they are doing things. It's not, these people are mad, man. I'm telling you. But AI and big data. So the AI landscape is constantly evolving. Everybody has a place in it. It's not an industry of its own. It's is used in all industries, in in cars, in fashion, in sports, for intimacy. When you go to a website and you type in, and then the chat bots, we call them chat bots. Like anytime you're chatting on a website and you're getting an automated response, that's chat bot is short for chat robot. Robotics, all of these things, the flying drones, they are processing data, GPS data. Amazon is trying to get drones to drop things in people's houses. All of this is powered by big data for artificial intelligence. That is mimicking the intelligence of man, teaching machines to begin to behave like men. And let me delve a little bit into spirituality. AI and big data, for me, is proof, shows just how amazing God is and the power of God's creation. The amount of data that we process to do anything at any time, to take a walk, a 1 mile walk, the amount of data you are processing, you will not be able to understand it until you begin to see how when they are teaching machines to do it. The amount of data it's capturing to take the next step, to gauge that where it's taking that step, there's a koto there, and it needs to stretch so that it doesn't fall. Something that we will just be going, just see, just step, just load. They gather so much data. So we too, we are gathering that data. We just don't know it because our brain is just that powerful. But to replicate it with machines, there's a lot of science behind. So data is massively generated on a daily basis, from our mobile devices to electronics to social media. There's too much data on social media. All of this is big data. And using that, they begin to science that data to the point that you can get a model out of it, a pattern. And using that pattern, you can make predictions of what's going to happen. Even we as human beings, let me use football, for instance. Larry and all the guys will understand this thing. If you watch a player like Cristiano Ronaldo or Lionel Messi or whatever for a long time, you can know their moves. T-boy, ball. Ronaldo must be there by now. He will throw the ball to whatever. So using patterns, you can develop models and do predictions. It's called predictive modeling. That is what AI is built of. It's one of the key parts of AI. So, and it's very, very broad. I essentially touched 3 parts of it: machine learning, deep learning, and natural language processing. Machine learning, using big data to make it easier for machines to work. All the different factories right now that are using robots and things like that, that's machine learning. There are more applications, there are more use cases that I didn't add here. But machine learning engineers, data science engineers, they are top of the food chain in terms of income, just because of how novel and new and radical, even revolutionary AI is. Then you have deep learning. It's an AI function that imitates the working of the human brain for processing data and creating decisions. So facial recognition, autonomous vehicles. There are computers right now that they will scan your iris. It's your eyeball that they will use to authenticate you in. Nobody else will be able to authenticate. There are security doors also, biometrics, that use biometrics. They'll use your thumbprint or they will use your eyes to and then they open the door. That's part of deep learning, artificial intelligence. Autonomous vehicles that Uber is trying to do, where they can learn a whole environment and they can drive themselves. In America, they have done autonomous trucking. The trucks that carry a lot of goods from one city to the other is already being done. Did you know? I didn't even know until I began to dig into this presentation to research. From city to city, trailer will drive. There'll be a driver in it, but it's just watching for emergency. The truck will drive itself. That's deep learning. This is insane. This is insane. And we're talking about this car will overtake cars and go back to its lane and all of that jargon. Just drive like a person is driving it. Natural language processing. So there are data scientists for deep learning. There are machine learning engineers. Natural language processing like Alexa, Cortana, all of these tools that we speak to, that you buy from Amazon and you speak to them and you ask them a question and they recognize your voice, they know what it means, or speak to them like Grammarly. If you write a whole essay, you can use Grammarly to help you, to tell you where your grammar is wrong. That's because of the massive amount of correct and incorrectly constructed English sentences that it has learned. So, it will correct it. It's a petabytes of data that loaded behind the scenes. So it will correct it for you. So that's why big data is the heart of AI. For any machine to mimic a human being, it's taking the data of that human, our senses, our natural senses, they are sensors for a lot of data that we put inside us. So this, I think when our kids are grown, as part to Kule's question, for instance, when our kids who are like 5 years old now and things like that, when they're in their 30s and 20s, this will have become so much more common. I think this might be one of the good areas to direct children, expose them to technology, let them see what is going on, how it is done, spark their curiosity. And then these guys get paid a whole lot of money. To get started, if you have background or affinity for mathematics, you study statistics, you studied mathematics and all of those highly number-centric courses, it shows that you have a penchant for this. All these certifications are out there that you can begin to do, to learn, to get into the world of data. You can't just jump to AI. I think like you have to grow to that point. You learn to that point. You know. Yeah, Ebenezer. So there are certain domains that I didn't touch today. Like under software development, there's ERP consulting. ERP is enterprise resource planning, like SAP, Oracle, Microsoft Dynamics. They do like Salesforce CRM. There's also CRM. These are not like AIO. These are like regular software development. I missed out that part. There are certain large software applications that organizations use, and they installing them, rolling them out, and teaching people how to use them becomes a job on its own just because of how large they are. They are called ERPs or CRMs. In the IT world, we use ServiceNow. It's a CRM. The leading one is called Salesforce. Microsoft Dynamics is another one. You will go and become an expert at that. You don't need to know infrastructure and all of that. It has nothing to do. It's like data. This one, you're just studying a specific application. You're learning how it works, how it is deployed. You will learn just as much core IT as needed to deploy it. And that's it. And then you begin to use it for people as a consultant or teach employees of a place how to use it. So there's a lot of jobs in that area. Salesforce, for instance, just Salesforce jobs alone, 30,000 jobs for Salesforce, where you have to know Salesforce, 30,000 just as of now, just because of just how big it is. So it's a CRM. You become an expert. They have certifications and trainings. You become very good at it. SAP is there, like I said. I think there are Oracle Fusion. There are very, very many. Microsoft Dynamics. If you learn these applications, you're working in IT as well, and you are, let me see, Microsoft Dynamics jobs. 38,000 jobs for Microsoft Dynamics alone. So this world of ERP implementation, CRM implementation and rollout is also approachable. It's one of the good places to start. We learn the application. You don't need to know you don't need to know anything about cybersecurity. That's not your business. You don't need to know anything about routers. It's not your business. You don't need to know too much about data. It's just the application, what it is used for, how it is used. You can be a master of it. There's a lot of jobs. There's a lot of organizations looking for experts in them. So, and then under cybersecurity, there's a subset of it called identity and access management that has essentially grown into a life of its own. I didn't touch it here because I didn't get enough information on it, but it's also there. The industry of IT is always reshaping itself. It's like an amoeba, always reshaping. It's the fast-changing industry. So what does it exist now? In 10 years, it will exist. And then it will need experts because there will be industries looking for it. So, but what we covered today is a good overview into what I would call the major parts of the IT landscape and the careers that come with them. Question time now.
Thank you. Can you remove us from live? Thank you.
We should stop live.
Yes, because this might lead to a different direction.
Okay. Of the live broadcast. Give me a second.
Adejuwon. Thank you.